12,000 years ago, Tasmania was part of mainland Australia. Then the sea rose, and it never looked back. Today, a radical idea is gaining traction, undoing that separation by building the most extreme bridge or tunnel the world has ever seen. That's not science fiction. This is a real conversation among engineers, politicians, and economists who see Tasmania's isolation as a bottleneck for growth, and maybe even a solvable one. The idea? A 240-kilometer connection between the Australian mainland and Tasmania, stretching across one of the most unpredictable and brutal bodies of water on Earth, the Bass Strait. The scale? Unprecedented. The cost? Staggering. The payoff? Potentially transformative. But before anyone can lay a single span or bore a single tunnel, we have to ask, is this even possible? Let's look at the history, the options, and what it would take to pull off the most ambitious infrastructure project Australia has ever imagined. This dream didn't appear out of nowhere. As early as the 1950s, visionaries talked about physically connecting Tasmania to the mainland. But back then, the scale alone was too intimidating, and the money simply wasn't there. By the 1990s, Tasmania's economic downturn made the idea more attractive. The island state was struggling with access to markets and tourism. Still, the price tag was enough to stop every proposal dead in its tracks. More recently, things have shifted. Ferry costs have surged, and Tasmania's energy export ambitions have sparked new conversations. The Marinus Link, a proposed 1,500 megawatt undersea electricity cable, isn't a bridge or tunnel, but it shows that massive undersea infrastructure between Tasmania and the mainland is being taken seriously again. The shortest route between Victoria and Tasmania is a straight 240-kilometer line across the Bass Strait. It looks simple on a map, but that stretch is deep, violent, and geologically unstable. Other routes are longer, but could offer better conditions. One option would detour through Flinders Island, increasing the length to about 250 kilometers. It means extra construction, but also shallower waters and better weather windows for work. Another option threads through King Island, reducing the water depth even more, but adding logistical complexity. Each route has trade-offs. The direct line is shortest and technically cleaner in terms of alignment, but it also exposes engineers to some of the most vicious marine conditions on the planet. And no matter which path you choose, you're staring down one unavoidable fact. This is going to be an engineering nightmare. So what if we tried to build a bridge? It would need to be nothing less than the longest sea bridge ever constructed, roughly 4 times the length of the Hong Kong-Zhuhai-Macau Bridge, which currently holds the record at 55 kilometers. Design-wise, you'd need a mix of suspension and cable-stayed spans, placed with extreme precision over deep, rocky seabeds. Bass Strait has sections over 150 meters deep, with violent wave action and winds that regularly exceed 100 kilometers per hour. And it sits right in the roaring 40s, the infamous wind belt that lashes southern Australia with brutal storms. Waves can hit 15 meters during bad weather, enough to put a serious strain on any exposed superstructure. There's also the risk of earthquakes. The region isn't the Pacific Ring of Fire, but seismic activity does happen, and that risk multiplies when you're dealing with enormous structural loads over a huge distance. The cost? At least $80 billion and likely more. That's 4 times the cost of the Hong Kong-Zhuhai-Macau Bridge, even before maintenance. And that's assuming it survives the elements. If the surface is too wild, could we go under it? A tunnel avoids the storms, but it brings its own horrors. Let's break it down. Shallow sections could use immersed tube segments like Copenhagen's Fehmarn Belt Tunnel. Deeper, rockier sections would need massive tunnel boring machines, similar to those used on Japan's Seikan Tunnel. Some engineers suggest floating submerged tunnels anchored to the seabed but suspended in the water column. Sounds wild, but Norway is already prototyping similar ideas. As for scale, Japan's Seikan Tunnel is 53 kilometers long and cost over $7 billion in 1988. A 240-kilometer tunnel across Bass Strait. You're easily looking at $40 to $50 billion, possibly much more if geology turns hostile. And then there's the practical side. How do you ventilate, light, and secure a tunnel longer than some countries? How do you evacuate in an emergency? How do you inspect it without grinding traffic to a halt? No one's done anything this long. Any project this massive carves through some of the most delicate ecosystems in the Southern Hemisphere. Bass Strait is a highway for marine life, including endangered whales and dolphins. Noise, pile driving, and seabed disruption could throw these ecosystems off balance. On land, you'd need access corridors that could cut through Tasmania's protected forests, home to rare species like the Tasmanian devil. Engineers could use low-noise construction methods and artificial reefs to soften the impact. But you're still talking about years of disruption. And environmental groups won't let this pass quietly. But let's flip the coin. Right now, everything Tasmania exports, from wine to seafood to timber, must be loaded onto ferries or short-haul flights. That raises prices and limits scale. A fixed link could mean cheaper freight, more tourism, and faster emergency access to and from the island. There's also the symbolism. A permanent connection between Tasmania and the mainland wouldn't just be economic, it would be national. It would rewrite how Australians think about distance and identity. And don't forget energy. Tasmania is rich in hydropower. A fixed connection could carry power, not just people. So what's stopping this? Right now, no Australian government has backed the idea in any serious way. The numbers are huge, and public appetite for mega infrastructure has cooled after cost overruns on other national projects. Even if it were built, the maintenance costs alone could rival smaller highway budgets. But technology is moving fast. Self-healing concrete, modular megastructures, and AI-controlled monitoring could change the math in the coming decades. If the Marinus link proves successful, it might open the door, just a crack, for something even bigger. So, could Australia really build a 240-kilometer bridge or tunnel across Bass Strait? Right now, it sounds like science fiction. But so did the Channel Tunnel once. So did high-speed rail in desert countries. So did floating airports. What's stopping us? Engineering? Money? Or just imagination? Would you drive across a 240-kilometer bridge in the middle of a storm? Or would a tunnel feel safer? Let me know in the comments. I'm curious which version of this madness you'd choose. And if you liked this deep dive, hit that like button so YouTube knows this is worth watching. Subscribe for more real stories about impossible projects and the people trying to make them happen.